Year 2, you are back and ready for another math skills lesson, which is great. I need you to make sure that your eyes are facing forward, looking at my screen to help us with our maths. Make sure those listening ears are turned on and we're ready to rock and roll. You might need a pen and piece of paper just to write some notes down, or you might need somebody to sit next to help you with your explanations, because I'm going to ask you to talk out loud. The key vocabulary we need for the 3 activities we are going to do today is part, whole, tens, ones, double, half, equal, augend, addend, total, and sum. So, these 2 words here, augend and addend. Some of us might not have heard those before. However, you are very used to working with the augend and the addend, because the augend is an amount that we have and the addend is the amount we are going to add to that. So it's simply addition. Okay, the augend, the amount that we already have, and the addend is the amount we are going to add to get us to our total or to our sum. Okay, so it'd be great if you can start using that vocabulary, recognizing which is the augend and which one is the addend. Great. Let's get started. We've got our very familiar part-whole model because we need to switch those brains on. Let's do something we're really good at, get that confidence flying high. As you can see, I have 1 revealed. You're going to help me solve that one. Then I'm going to actually reveal 2 for you to work on yourself. Okay, so thinking out loud, let's have a little look at what we have got here. We have got the whole of 88. We have a part of 8, meaning our missing part must be 88. We've got 8 is 80. Thank you very much for your help. So we know 80 and 8 makes 88. How many tens do we have in 80? We have 8 tens and we have 8 ones to make 88. So we've got the whole of 88. So we're going to be looking at different wholes and how different parts can make that whole. Sometimes the parts might be equal, sometimes the parts might be unequal. They are not the same. Great. Have a little look at these 2 part-whole models and solve them by pausing the screen to give yourself more working out time. Off you go. Great. Hopefully you should recognise that 35 can be partitioned into 30 and 5, and 109 can be partitioned into 109. At the moment we are partitioning into the place value columns. However, later on we will be partitioning into different amounts. Great. Help me with this one. As you can see, it's not place value anymore. We've got the whole of 82. We've got 60 and we've got something else. What is that something else? How much more do I need from 60 to get me to 82? 70, 80. So I needed 2 tens. So I needed 2 tens and how many ones? And 2 ones. 80, 81, 82. 70, 80, 2 tens, 81, 82, 2 ones. Great. So so we know that 60 and 22 makes 82. Great work. And that means we have 8 tens and we have 2 ones that make 82. So 8 tens are being split up into 6 tens and 2 tens, and our 2 ones are there to get us to 82. Right now, you've got 2 part-whole models that you need to complete. Pause the screen to give yourself enough working out time. Off you go. Great, so looking at 40 and 15, we can hopefully recognise we've got 1 10 in there, so 1 more 10 to 40, 40, 50, add the 5, 55. Great work. Now we've got 20 and 22, double 20, 2 tens, 4 tens, 40, 2. Great work. So hopefully we should be able to do that maths in our head. Look at the 10s, combine them together. Look at the 1s, combine those together and get those numbers together. Great work. So again, you're going to help me, but as you can see, this part whole model has an extension. Yeah, nice big extension. It has been partitioned into even smaller parts. So we've got 50, and we know that this part is actually made up of 4 and 5. 4 and 5 is 9. So then we've got the whole of 50 and 9, 59. Great work. Thank you very much for your help. So that means we have got 50 and 9 makes 59. How many 10s are there? Yep, there are 5 10s as we can see, but there are 9 1s that make 59. We've got our 5 10s that make 50, our 9 1s to get us to 59. And a part of 4 and a part of 5 1s gives us that part of 9 1s. Great, you have now got 2 part whole models that I would like you to work with. Pause the screen to give yourself more working out time. Right, great. So we've got 31, a part of 31. We're not quite sure what the other part is, and we definitely don't know the whole yet. The other part is made up of 50 and 1. 50 and 1 is 51. Now we can get 31 and 51 together. So 5 10s and 3 10s, 8 10s, the 1 and the 1, 2 1s. So we've got 82. Great. And then when we look over here, we've got a part of 43 and a part of 20, 43, 53, 63. So when we're counting our 10s, we get the whole of 63 and partitioning 20. There are many, many different ways to partition 20. You can choose which one you see as the most efficient. You might do 18 and 2, you could do 10 and 10, 19 and 1, it is up to you, but it needs to make the whole of 20. Good work. Now you can see we've got 6 different part whole models. Some have the whole already given to you, some don't, some have extra parts. You need to spend the time now to complete these part whole models. Pause the screen, give yourself some working out time, off you go. Great, so we'll start over here. We have got 5 and 5, that makes that part of 10. So now we know we've got 10, we're trying to get that whole of 100. So if we take, we've got our 10 10s of 100, we take one of the 10s off, we know we're left with 9 10s. So we know 90 and 10 make 100. We move over to 39 over here. We actually had the part of 6 already. So if we take 6 off 39, or we just take 6 off 9, we know we're left with 3, we're left with 33. And then you can partition 6 in the different ways that you choose to. But I'm going to use the half fact, 3, and 3 gives us 6. You could choose 5 and 1, 2 and 4, 0 and 6, it's up to you. Moving across, we've now got 25 and 35. Actually, you know that double 25 is 50. Well, we've got an extra 10, so meaning that we must have 10 more than 50, which is 60. Great work. Some of you might have just added the 2 5s, got a 10, added the 20, added the 30, and still got 60. And again, 35 can be partitioned in many different ways. You might go 20 and 15, 30 and 5, 34 and 1. Get your adult to check your partitioning of 35. Moving back to 100, we have 55 as a part. So we need to know what else is needed in this part. So we've got 55 as a part. What is missing? 5 more will give us 60. Then we need 4 10s, don't we? So we need actually 45 in this part whole model. So we've got 45 as our smaller whole. We then have 15 already. So I take the 15 off the 45, take the 5 off, left with 40, take another 10 off, left with 30. Good work. Now this part whole model, the 33 and the 23, the 3's give us 6, and the 30 and the 20 gives us 50, 30, 40, 50, 56. And again, your 23 can be partitioned in many different ways. You might go place value of 20 and 3, 21 and 2, it is up to you. Now, we've got 19. We're not quite sure on the whole or the other part, but we've got the information we need to get that other part. We've got 19 and 11. 19 of the 1 of 11 gives us 20, add the 10, gives us 30. Now we've got 30 and 19. So 30 and 19, 30 add the 10, 40 add the 9, 49. Some of you might have chosen to add 20. 30 add the 20, 50 take 1 off, 49. Again, just as efficient. Well done. We now want to exercise 2, so activity 2, where we are going to be adding some more. But when we are adding, or adding two amounts, there are different ways we can add numbers. So we get taught column method, we get taught to add in our head, and we get taught to partition numbers to add them together to help us be more efficient. And some methods work better than others for certain calculations. So we're going to look at a calculation. We're firstly going to solve it by mentally partitioning our numbers, and then we are going to solve it with column addition, but I've covered that because we're going to focus on mental partitioning first. So if we're looking at 23, I want us to partition 23 into its tens and ones. So 23 can be partitioned into 20 and 3. So what can 25 be partitioned in? Help me out. It can be partitioned into 20 and 5. And because we know that, we can make adding two numbers, 23 and 25, a lot easier for us. So the 20 and the 20, 2 lots of 20 gives us 40, 20, 30, 40, and the 3 and the 5 gives us 8. So 40 and 8 gives us 48. Great. So by splitting our numbers or partitioning our numbers into smaller parts, we can add them together and combine them to make our life easier when adding two numbers. Okay, so that was quite an efficient method, wasn't it, for that calculation because the numbers are nice and small. Now let's have a check with our column addition, see if we get the same result. We've got that same total, we've got 23 and 25. Where do I start when we are using our column addition? Yes, we'll start in the ones column. 3 and 5, 5 and the 3 together gives us 8. And 2 and 2 gives us 4. So we've got the same total. We've got the same sum. We've got 48. So there's two different strategies we used there to help us solve this addition number sentence. We had the org end of 23. We added the add end of 25 to get us to the total, the sum of 48, using mental partitioning and column method. Okay, hopefully you got the same result. Now, I would like you to solve this addition calculation, adding the org end of 42 with the add end of 36 by partitioning the numbers and combining them together. So partition, recombine. Partition, then recombine. Pause the screen to give yourself some work now time. Great, so we should hopefully have partitioned into 40 and 2, 30 and 6. Then we can combine 40 and 30. 40, 30 is 70. And then we've got 2 and 6, which is 8. Then we've got 70 and 8 is 78. Great work. Now let's have a little look at it in our column method. You have a go first by pausing the screen and giving yourself some working out time and see if we get the same total. Off you go. Great work. So we should hopefully have 42 and 36. We start with our 1, 6 and the 2 gives us 8. Then we move to our 10s with 4 10s and 3 10s, which gives us 7 10s. And again, we get the same result of 78. Okay, so when we're thinking about partitioning our numbers, giving us a real good understanding of why we do it, and then moving over to our column method, we can do it just as efficiently. Okay, this method will support you in being able to do it more efficiently in your head. Again, we've got a different calculation. We've got the org end of 51 this time, and you're going to add the add end of 49, and we're going to see what we get. Okay, so partition your numbers, recombine, and see what total or sum you get. Pause the screen, give yourself some working out time. Great, we're back in, so partitioning 51 into 50 and 1, 49 into 40 and 9. I don't know about you, but I've spotted 1 and 9 straight off. Gives us 10. And 50 and 40. 5 tens, 4 tens gives us 9 tens, which is 90. 90 and 10. 90 and 10 more gives us 100. Great work. It's lovely when you get a bond there, isn't it? Then we get 51. Add 49. Right, so where do we start? We start with our ones. Right, well, you do it then. I'm not doing your work for you. Pause the screen, give yourself some working out time. Brilliant, so we start with our ones. And 1 and 9 is 10, isn't it? I'm just going to write that here. It's a 10. Can we fit 10 in our ones column? No, we can't. How many ones do we have? We have 0 ones and we have 1 10. So it's 0 ones, 1 10. So we'll just pop that on our doorstep while we wait. Then we've got 5, 4 and 1 10. So we've got 5 tens, add the 4, add the 1 gives us 10 tens. Which again, we've got 0 tens and we've got 100, haven't we? So we've got the result of 100. So our total of 51 and 49 is 100. Which method was more efficient? Yeah, this method was, wasn't it? Once we spotted the bond of 1 and 9, we got 10. And we got 50 and 40, we got 90. We could get that straight together. Whereas this one, we've got to think about carrying over. Great, well done. So, you've got a different calculation this time. The org end of 16 and the add end of 75. We are going to see what our total or sum is by firstly mentally partitioning. Partition your numbers, recombine them to see what result you get. Off you go. Pause the screen if you'd like more time. Right, 16 can be partitioned into 10 and 6, and 75 can be partitioned into 70 and 5. 70 and 10, great. That gives us 80. 70, 10 more is 80, and 6 and 5, quick addition. Need double of 6 and 6 is 12, 1 less is 11. So we need 80 and 11. 80, 10 more is 90, add the 1, 91. Right, now let's see by using the column method whether you get the same total or sum. Off you go, pause the screen to give yourself working out time. Right, we're back in. Let's look at 16. Oh, get my pen. 16 add 75. Where do we start? We start at the ones. 6 ones add 5 ones is 11 ones. So when we look at 11 ones, we've actually got 11 ones is actually made up of 1 1 and 1 10. So we can put our 1 in the ones column and we need 1 more 10. So now we're not adding just 1 10 and 7 10, we're actually adding 1 10, 1 10, then 7 tens. And as you can see, we get 9 tens as a result of that. So our total is 91. So we can see how this mental partitioning and also this column method give us the same total. Okay? Right. Now, you've got 3 different calculations here for you to be working on. You can choose whether you can do it mentally partitioning, column, or you can choose to do it both and then compare. Well, you've got 3 calculations to solve, and then we can check to see how you get on. Pause the screen, give yourself some working out time. Right, that's great. Let's have a little check. So if we went for the mental partition of 35 and 33, let's see what we end up with. We partition into 30 and 5 and 30 and 3. We know that 2 lots of 30 is going to give us 60, and a 5 and a 3 is going to give us 8. 60 and 8 will give us 68. Fantastic. We might then choose to do column addition for 44, the organ of 44 with the add-in of 53. Starting with our 1s, remember, 4 and 3 gives us 7, and 4 and 5 tens gives us 9 tens, which gives us 97. And then, again with 35 and 27, we might actually choose to go to this strategy. You might have done it with the column method, which is again an efficient method, but you might have chosen this one instead. 35, add the 27, then we can partition 35 into 30 and 5, the 27 into 20 and 7, the 30 and the 20 come together for 50, and the 5 and the 7 come together as 12. 50 at the 12, 50, 62 will be your total there. So well done if you managed to get that. It's our second activity done and dusted. Fantastic mathematics from you there. Hopefully you've seen this activity before, the house of. Can you please tell me which house we are working with in this session? Yes, we are working with the house of 83. And as you know the rules, only items that represent 83 are allowed to enter this household. Those that don't represent 83 are not allowed in the household. So you're going to help me find which ones can and which one cannot enter this house of 83. You ready? We'll do a couple together, then I'm going to even you, right? So we've got our 10s here. We've got 10, 20, 30, 40, 50, 60, 70, 80, 81, 2, 3. Yes, we do. We have 83. So what does that mean? It can go inside the house of 83. So buy the Numicon. What about the money? Let's have a little look. What have we got? We've got 50, 20, 10, 2. 50 add the 20, 50, 60, 70. Add the other 10, 80. 80 add the 2, 82 pence. Can 82 pence enter the house? No, 82 pence cannot enter the house. How much more would we need? We would need one more penny, wouldn't we? But unfortunately, we don't have that quite yet. And we'll do one number sentence together. 100, take away 15. So I've got 100, take away 10. It's going to leave us with 90. And 90 take away 5. 89, 88, 87, 86, 85. So that equals 85. Can that enter the house of 83? No, that definitely can't enter the house of 83 because we've got too many. Good explanation. Right, now look at another number sentence. The 10 sticks and cubes, and then also your Papa home model to find out if anything else can enter our house of 83. Off you go. Right, what can enter our house of 83? 50 and 33, can that? 50, add the 30, 60, 70, 80, add the 3 is 83. So yes, that can enter our house of 83, and it's in. Great work. What about our 10 sticks? How many 10 sticks do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. 8 sticks, 3 cubes, 8 tens, 3 ones is 83. Great work. It can enter the house. And what about our 41 and 42? 40 and 40 gives us 80, 82, 83. Yes, it can enter our house of 83. Absolutely fantastic work. You've got a house to solve all by yourself. I'm not going to speak until you've finished. The house of which number this time? We have the house of 68. So yes, you're working with the house of 68. Find out which representations can enter our house of 68, but also the ones that can't. And if you found the ones that can't, think about what needs to happen for them to be able to go into the house. So find the ones that can, find the ones that can't, but also explain what we can do to those ones that can't to allow them into the house. Off you go, pause that screen to give yourself working out time. Right, what have you found out? We've got 10, 20, 30, 40, 50, 60, 8. Yes, Numicon is in. 60 and 8? Fantastic, it's an easy one, isn't it? 60 and 8, we're straight in. What about 30 and 30 and 4 and 4? 3 tens, 3 tens is 6 tens. 4 and 4 is 8. 6 tens and 8. Yes, we're there. 68. Great work. What about the money this time? 20, 20, 20, 20, 40, 60, 65, 66, 67, 68. The money's in. 68 pence we've got. Great. What about our part whole model? 60 and 8 is definitely 68. Happy again. There's lots of 68s. There's lots of people going in this house. Then we've got 20, 20. 20 and 20 is 40. 50, 60, 62, 64. Can that go in the house? No, it can't. What would need to happen for it to be able to go in the house? Yes, the issue is this 4 pence. Isn't it? We've only got 64 pence. What do we need? We need another lot of 4 pence. So we're going to need 2 pence and 2 pence to get us to 68. Great work. Then we've got 100, take away 40, add 7. So 100, take away 40, 4 tens, leaves us 6 tens, add 7, 67. Is that right? Can that go in the house? What would need to happen? This would need to change, wouldn't it? We'd need to add 1 more. So we need 1 more than 7, which would be 8. Or we might have just subtracted 1 less than 39. So we need 1 less from there, and we could have subtracted 39, rather than 40. Great work. Because you are so good at this activity, I'm leaving this last activity up to you. Very open. Don't know what the house is yet. You get to decide. But I would like you to draw or write lots of different representations that would be allowed in that house. However, don't forget, trick that parent of yours, trick that adult in your household. Do one that isn't allowed in the house. See if they can spot and correct to get it in the house. So do lots of representations of your house number, but then also do one representation that isn't in that house. Off you go. Pause the screen to give yourself more time. Hopefully you managed to trick your adult. Well done for joining today, year 2. That's 3 activities done and dusted. Keep up with that maths practice at home. It's been great having you. Bye.